Alright, in this video we're going to be using the chain, or I'm going to teach you how to use the chain rule. Now the way I learned this in school, I didn't really like the way the teacher did it, so I'm just going to try to explain it the way I thought was the easiest to learn this. Alright, so let's get right into this. It should, by the end of this video, you should have a pretty good idea if you were doubtful if you knew how to do it. So I will show you how to do it. And here we go. Alright, so for this, we're basically peeling away these functions like an onion. We're taking the derivative of the outside while ignoring the inside, and then just taking what that was and taking the derivative of the inside. I shouldn't have said ignoring the inside, but I'll show you. All right, just step by step. All right, you'll see what I meant. We have sine of x squared. So this is actually equal to sine. The derivative of sine is actually cosine, if you remember from when you've learned it. Alright, so then this is cosine x squared. So then when we take the derivative of the outside, it's equal to this. Then we take the derivative of the inside of this. So this would be equal to 2 times 2x. So technically the derivative of this is 2x cosine x squared. That's the derivative of sine x squared using the chain rule. So this is that derivative. And how different way to explain it, you just take the derivative of the outside and with the entire thing, then you take the derivative of the inside and multiply that times the derivative of the outside. I can show you more examples doing this. Do a few more examples. I'm going to find the derivative of, let's see, 8 times 3x to the fourth minus 2x. Alright, yeah, we're going to find the derivative of this. Remember, we can rewrite anything to the radical. Like this might be a trick question if you get like this on a quiz or something. You'll be like, oh, I don't know what to do now because of the radical sign, but don't panic. Just, this is actually equivalent to 8 times the quantity x to the fourth minus 2x to the 1/2. Because remember, when you take the square root of something, it's the same as taking it to the 1/2, the exponent to the 1/2. So we're actually going to combine the power rule that I taught you in another video with the chain rule. So what we're going to do is multiply 8 times 1/2. And then remember 8 over 2 is 4. So this is going to simplify to 4 times 3x to the fourth minus 2x. And then remember we subtract 1 using the power rule. Remember we used the power rule, we used to subtract 1 from the exponent. So this is going to be negative 1 over 2 times, then remember after we peel away the outside, we take the derivative of what's on the inside. So this will give us 12x to the third minus 2. So that's on the inside. And then, depending on your teacher, you don't really have to simplify it. I mean, you could technically write the answer as 4 times 12x to the third minus 2 all over radical 3x to the fourth minus 2x. Because remember, this is a negative 1/2, so we can bring it downstairs, and this 4 will stay up. So then you can technically distribute this. I wouldn't, because if you were trying to find the equation of a tangent line, like I showed you before, it's actually easier to solve it this way. Actually, it depends on the problem, what x they give you, but you get what I mean. So this is the derivative using the chain rule of this right here. So hopefully that was pretty helpful. I'm going to do a few more examples just to drill in the point. Alright, so we're going to find the derivative of, using the chain rule, of 5 times 2x to the third minus 3x squared all to the 3/5. Now, it's basically the same thing as the other one. We're going to multiply times the exponent. So we're actually going to get 5 times 3 over 5, which will be equal to 3, because 5 times 3 is 15 divided by 3. 5 is 3. So we're going to be left with 3 times 2x to the third minus 3x squared. And then remember, we multiply times not multiply, we take the derivative of the inside. So that is going to be equal to 6x squared minus 6x. So then, oh wait, I almost forgot, minus 5 over 5. So this is going to be equal to minus 2 over 5. That's minus 2 over 5, because you have to get the common denominator, because 5 over 5 would be the same as 1, and this becomes, because 3 minus 5 over 5 minus 5 is negative, so it's that. So we can bring this downstairs at 2x to the third minus 3x squared downstairs, so we're actually left with 3 times 6x squared minus 6x all over 2x to the third minus 3x squared, or quantity to the 2 over 5. 2 over 5. So this right here is the derivative using the chain rule of that function up there. I mean, just practice makes perfect. You just can keep doing examples just till you eventually get it drilled in your head. I like to keep it to a specific never mind. Alright, we're going to find the derivative. Again, we're doing another problem, another example of sine squared x. Alright, so this is another trick that the professor might give you, or teacher. This is actually the same thing as sine of x quantity squared. So you can visualize this better more than this one, because you can see the power up there. So this is going to just be equal to 2 times the inside sine of x times the derivative of what's on the inside, which would be cosine x. So this is actually equal to 2 sine x cosine x. And this is the derivative, using the chain rule, of this one up here. So remember, you just take the power rule, and then rewrite the function after you take the power rule. Oh, this is minus 1. So anything to the 1 is just, you don't have to even bother writing that. And then we just take the derivative of the inside and multiply it times the original, times this function, and that's your derivative. We're going to do 2 more problems using E, Euler's number. 2.7 is my favorite. So we're going to have e to the 3x plus 4. E can be a bit tricky. You just have to know. Like, this is just something you pick up, you memorize as you go along. I guess basically by the time you get into Calc 2, it would be ingrained into your head. Alright, so you know that e of x, the derivative of f of x equals e. Any derivative, like you could write, or just to over-exaggerate, it could be f to the, what is that, the 7th, 4, 5, 6, 8th derivative of x, of e to the x is e to the x. So remember, e to the x is always e to the x when you take the derivative. That's always constant. So for this, it's going to be, oh, oops, sorry, I have stuff to get used to this. Filming, moving the camera around. So this would be, so it's technically, this is actually equal to e to the 3x plus 4, it's this entire thing, times the derivative of what's up here. So that's times 3. So we're left with e times, or 3e times 3x plus 4. And it really is that simple. This is the derivative. It's like one line I just did. I'm just taking, because he's the constant. You don't have to bring. There's no power rule involved here. Well, like you don't bring down anything like we did in the other ones. We just take e to write the entire thing, and then just take the derivative of what's on the exponent, which would be 3. 3x plus 4. Derivative of that is 3. And then just bring it out front. So it's 3e. And then for one last problem, I'm not going to erase that. We're going to have 11e. Like if we had a coefficient in the front. Oops, off screen. If we had a coefficient in front such as 11, this would actually this would be equal e to the 11th, 3x plus 4, times 3, just like from up here. Oops, yeah, I want to erase it just so I could prove my point. From there. And then you just multiply 3 times 11, and you're left with 33e 3x plus 4. And this is the derivative here. So even if there's a coefficient out front, you just basically ignore that for problems that look like this when you're using the chain rule. Just rewriting the entire thing and then just taking the derivative of what's in the exponent and multiplying that times that equation, which would give us 33. E to the 3x plus 4. Alright, I hope this video was helpful in terms of the chain rule. Remember, it's like peeling away layers like an onion. You take the derivative of the outside, well, you multiply the exponent through if you're using the power rule, and then rewrite that, and then you take the derivative of the inside. I mean, practice makes perfect. You may have to do a lot more of these problems just to get it ingrained. I know I did when I was learning this. So you can just keep practicing with that, and that is the chain rule. So there you go. This video is as long as some of my other ones. Alright, so there you go. Hope it was helpful.